We're going to begin the day's proceedings really with a background paper, a paper that I'm hoping will set the tone for the whole day. It will be given by Professor Ernest Moniz, who is a professor of physics at MIT, where he has served on the faculty since 1973. Professor Moniz served as Undersecretary of the Department of Energy from October 1997 until January 2001. In 2006, he was named Director of the MIT Energy Initiative, which was formed by MIT President Susan Hockfield to address the science, technology, policy, and systems design required to meet the global energy challenge. Professor Moniz.
Well, thank you, Ken. I'd like to maybe just make one refinement of the introduction. That stint as Undersecretary was until noon on January 20th, 2001, to be more precise. For those of you who know the political rhythm, that has obvious implications. In any case, again, I do want to thank Ken and thank Yossi also for the invitation to come and open up this conference, although for truth in advertising, I think, as you will see, this is not focusing directly on your issue of energy efficiency and supply chains, but rather one that provides a little bit of the context of the energy world, the energy challenges that we see going forward, and which we just heard also, of course, drives a lot of the volatility and interest in the subject, and also to say a few words about our initiative at MIT. That'll be very brief, but I will say it from the point of view of hoping that, in fact, the study, the analysis of the issues that you will be focusing on much more specifically, in fact, will be part of our agenda, because we believe that, first of all, efficiency in a general sense is an absolutely key focus for any serious look at the future of energy and the environment, and then merging that with supply chains, for example, is really a very important, in our view, area for research. So again, I will just give this kind of context, and I'll start with just a quote from Susan Hockfield when she, in her essentially first formal act at the Institute, her inauguration, rather surprised a lot of people for a neuroscientist by saying that a focus on energy was going to be one of the kind of institutional commitments that she wanted to see made at the Institute. And I think the words chosen, I don't want to read this whole quote, but the words chosen, like obligation and responsibility, is a rather interesting set of words for a university. And I think what it reflects is the idea, strongly resonant with the faculty and even more the students, that applying the kinds of tools that we are accustomed to using, whether it's in science and engineering or management and economics, that applying those tools to energy and the environment in the 21st century is one of the most direct ways, frankly, of addressing human needs, particularly in the global context. So that's really kind of the highest level way in which we see this whole subject coming together. And again, today's topic is a very important one. So with that, let me just say reasonably briefly, as brief as academics can be, again, how we are framing the initiative, and hopefully that helps to kind of frame also the discussion today in terms of the broader energy context. By the way, also, if there are comments or questions, anytime, please let's interact as best we can in this rather informal setting with a podium, et cetera. Anyway, basically, there are kind of, generally speaking, three major drivers of our considerations of how we move forward in energy and associated environmental challenges. There is the projected very significant requirement for enhanced energy supply. That is, of course, directly relevant to the issues at hand here. Secondly, there is a set of issues revolving around energy and security, only one of which, but one that gets the most public attention and maybe the most directly relevant here as well, is that around oil supply and its attendant relatively high prices, its volatility, et cetera. And third, energy and environment, where among a whole variety of environmental problems, that which stands out in terms of its challenge to the current energy infrastructure is climate change. It stands out because, as you know, roughly 80% of global energy use is driven by fossil fuels. In fossil fuels, carbon is not exactly a small impurity, and therefore controlling carbon is a pretty big challenge to a fossil fuel dominated system. And the issue is really, in the end, addressing all three of these in a synergistic way, which is where a challenge, in fact, comes. For example, doubling energy supply, tripling electricity use by mid-century while controlling carbon can lead to some interesting choices down the road. On the other hand, there are synergies, because if you want to address, let's say, the oil problem, fundamentally you are addressing a carbon issue, as you are with climate change. So how one finds the intersection of technologies and policies will be itself a major challenge. So let me say a few words about these in a bit more detail, but not to go through every last wonderful factoid. First, in terms of supply and demand, I think the first thing in discussing the energy issue, and I think it applies very well to the issue of supply chains and the very substantial amounts of energy used, of course, in the transportation and freight sectors, is it's a good thing to start with what the hell is the scale of this enterprise. It's the world's biggest business, and if you look at the burn rate of energy globally today, it's about 14 terawatts. Okay, that's the rate at which we use energy globally today. 16 tera kilowatt hours. This is a multi-trillion-dollar-a-year business. In the energy business, we often wonder, why is it that energy technology seems to turn over so slowly? For example, a few weeks ago, Jeff Immelt, the GE CEO, was here for a conference, a weekend conference organized by the students. He made the point that he's been at GE for the order of a quarter century. And he says, and I will just quote him, I won't verify the statement, but it rings true, is that in that period of time, GE is now in its 5th turnover of medical technologies that it sells. What it sells today has no resemblance whatsoever to what it sold when he started at GE. But with improvements in efficiency from 35 to 39%, et cetera, fundamentally it's the same product line in energy. Turbines, you name it. And one of the reasons is that, let's take the oil business. Again, we're talking about trillion-dollar scale. We're talking about what is fundamentally a commodity, and we're talking about an incredibly finely tuned supply chain that takes oil out of the ground somewhere, provides finished products on a global geographical scale, and that is not a business which invites, put it technically, screwing around. And so, it's inherently a business that has a huge amount of inertia. And I think that is also one of the issues to be discussed ultimately in the issue that you are addressing. Anyway, there's a variety of other issues here. One that is relevant, perhaps, is the last one that, again, as you know, I think, so that inertia that I'm talking about might be characterized by, say, a 50-year time scale. If you look historically at the time over which, let's say, market share of different fuels changes substantially, one is literally talking 50 years. So it's a slow-moving business, you may move much more rapidly in terms of how you adjust your supply chain, but that's in the context of an overall energy supply system that we shouldn't expect to be dominated by solar power next year. Actually, this is just a figure that's of some interest, I think. This is focusing on electricity, but it makes an interesting point. We talk about these kinds of bloodless numbers like tripling of electricity supply to mid-century. This is a little bit of an aside, but I think it might be interesting, because it gives you an idea of what it means to, let's say, triple electricity supply. We could do a similar thing for doubling energy supply more broadly. But this plots annual per capita electricity use versus the UN Human Development Index. The latter is a somewhat qualitative mix of educational, health, and economic indicators per capita. And as you see, there's a kind of empirical trajectory there. Roughly speaking, 0.9 on a scale of 0 to 1 kind of says you've made it. That's kind of the quality of life success threshold. And you see all those green dots are basically the industrialized countries, and whether you are at roughly 4,000 kilowatt hours per person per year or 13,000 as in the United States, your human development is 0.9. As you see, things then fall off south pretty quickly. All those purple dots which accumulate against the origin is Africa, for example. But the point is that if you separate the global population into those people in that plot who are from even, say, 3,000 kilowatt hours per person and above, that's about 1 billion people out of the world's 6 billion people. The other 5 billion are somewhere down that trajectory. What 4,000 kilowatt hours per person, what tripling electricity to mid-century means is roughly moving 5 billion people by mid-century up to, say, 4,000. Unfortunately, there are those new 3 billion people at mid-century who are still going to be down there at the origins. That kind of gives you an idea. I mean, even a tripling, which is a massive, you think about the capitalization requirements for this, is still an issue of serving human needs, which is very, very important. Anyway, that's a little bit of an aside, but puts kind of more of a human face on some of these numbers. I'll skip the New Yorker cartoons, although they are, well, this may be of interest to you in your supply chain management, but let's go. The next issue in that perfect storm, there's demand, security, environment. So security, as I said, there are actually a number of issues involving energy and security, including things like nuclear weapons proliferation. That's kind of today's Iran story. Vulnerability of extended energy delivery systems. It could be a terrorist story, but frankly, it's more likely a hurricane story, et cetera. But again, the one that we have the most discussion of is just the question of the geological and geopolitical realities of oil, particularly oil, also increasingly natural gas supply, and what that means. Now, what it means has been interpreted or misinterpreted in a completely stable, bipartisan way for many years, and this fundamentally nonsensical sentence, as I say, has belies the statement that we don't have a consistent bipartisan energy policy. We have one that revolves around a silly statement. And if one looks at the early stages of the 2008 campaign, whoever's face appears next will now have the bubble over it now. And it will be as meaningful as the earlier statements. So what do we really mean in addressing this problem of security? What I would argue is it's simply that the really core issue, it's not about energy independence, it's not about oil independence, it's not frankly about oil imports per se. It's about inelasticity of the transportation fuels market. And that ultimately is what leads to this very tight situation. Periodically, it leads to price volatility. So it's really about addressing this question of the inelasticity in transportation fuels, which globally is essentially like 97% petroleum-based. And so we really have no substitute, I remind you, in sharp contrast to the power system. But we have lots and lots of different fuels, lots of fungibility. We dispatch different plants at different times depending on fuel costs. So you really have kind of an arbitrage in the power system that you simply do not have in the transportation world. As I say here, there are a variety of ways of addressing this issue. There are policy-driven approaches, one of which, by the way, it's important to emphasize, because it's not usually, is the extent to which one supports a really functioning global market is itself a security step. And in fact, that was shown in the post-Katrina events. The impact was surprisingly short-lived because the market operated. Essentially, again, an arbitrage operated. Oil went to different places. It's an important issue. Supporting the market is itself an energy security move, which of course is a statement exactly opposite to stop oil imports. So anyway, you can think it through. You may disagree, but at least that's a different perspective. Secondly, of course, we want to diversify supplies. As you probably know, in the Western Hemisphere, Canada, Venezuela, if you take kind of bad molecules of oil, like in tar sands and in heavy oil in Venezuela, there's a lot of molecules. It's just that they cost a bit more. They have both an economic and environmental cost, but certainly that's an example of diversifying supplies. And finally, weakening the addiction, efficiency and alternative fuels are key. And efficiency here, I say efficient vehicles, one could also add there efficient supply chains would be a way of, in fact, gaining those efficiency. And this is really a set of tools that would address what is, in my view, the real underlying economic and security concern revolving around oil. Third, as I mentioned, climate change. I think that most of us certainly expect that the United States will very soon join into a carbon control regime. That is, we will price carbon dioxide. If you take a informal poll at any bar around Capitol Hill, I think you would find 50-50 a bet that we will even have a policy put in place, not necessarily the price put in place, but a policy put in place in this administration. If it doesn't happen in this, you'll see. Yes, that's what I said. The feeling is there's a non-trivial chance that a policy will get put in place in this administration. The feeling is much, much stronger if you put, let's say, a 5 to 6 year timeline, certainly by 2012. But this can happen. You know, I remind, well, those of you who go back to the implementation of the sulfur cap and trade systems basically for coal plants might remember how that goes. No, 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 and then suddenly it goes very fast. And because when enough congressmen decide it's going to happen, they want to rush to the table to get allocations for their constituents. And so we will see whether that's relived, but I think basically it would certainly be, I think, imprudent for any energy-dependent business executive not to be at least thinking about the options for living in a world where carbon is priced. we could go, I mean, I'd be happy to discuss at least my view as to how that's likely to happen, but there will certainly be a much stronger pressure, everyone believes, rather than that exemplified so far in Europe, in Europe's initial trading scheme, to make it a cross-sector and to one way or another pull transportation into the carbon control regime, as opposed to going for the politically more expedient approach of really focusing on large point sources, coal plants. Anyway, one point I wanted to make, and I apologize for this cartoon, but and I won't go through all of it, but I think it's often worth doing some arithmetic. But the numbers shown here are billions of metric tons of carbon. If you want CO2, multiplied by 44/12, almost 4. So I'm just doing carbon. Of course, the carbon is in CO2, but doing carbon. That tracks more easily to the initial fuel carbon content. Anyway, the point is very simply here, and again, I won't go through all the numbers, but roughly speaking, we emit globally around 7 gigatons per year of carbon, most of which comes from fossil fuel combustion. Land use is the other major source. If we, however, fold into that the net absorption of CO2 that occurs in oceans and soils and vegetation, then roughly half of it is a net increase. So we're increasing the net carbon load in the atmosphere by about 3.5 gigatons per year. Secondly, we are now about a third above pre-industrial levels. That's 750 gigatons in the atmosphere. So simple calculation tells you, therefore, that 1,100 gigatons in the atmosphere plus 350 would be doubling pre-industrial. I say doubling pre-industrial as a benchmark because the one assertion I will make is, taking the whole ensemble of climate analyses, doubling pre-industrial is viewed as kind of the outer limits of prudent management of our atmosphere. Most environmental groups would say that is wildly imprudent, that we should be aiming for maybe 80% of that, but I'm going to take the outer edge of prudence, doubling. So that's 350 gigatons left to go. It's a budget because the CO2 has centuries timescale of residence in the atmosphere, so it just accumulates. So we and our 6 billion colleagues have got a CO2 budget. At 3.5 gigatons a year into 350, magically, it's 100 years. But of course, that doubling of energy projected to mid-century essentially brings the 100 years down to around 60 years. If you lower the doubling, you're to 40 years. So fundamentally, all I'm saying is simple arithmetic. If you accept doubling as kind of a planning horizon, that's why it's a problem of this half century. But since it takes a half century to turn over the energy infrastructure, that's why it's a problem of now. If we don't start turning how the energy infrastructure revolves, we're out of time. And so that's why I think we will see considerable pressure, in fact, and U.S. participation in a climate regime very, very soon. The issue is whether we will have the political will to, in fact, manage that change of slope rapidly enough to converge in 2050, or whether we have our more traditional policy in which we make believe we're doing something. And again, I'm happy to discuss my view as to how that will go. But so those are the three kind of major drivers. And here I just now finally say for the United States, here is the pattern of carbon emissions now in carbon megatons. And I think of relevance here is, if we look at the two big numbers on this chart, there's a lot of numbers on this chart. Let's just look at 2005. look at the two big numbers, obviously. That is the electricity servicing residential and commercial buildings, presumably relevant to many of you, that's particularly the commercial building part. You know, in the United States, roughly 70% of our electricity goes into serving residential and commercial buildings. And of course, the big driver of that number is in the United States, is the coal-supplied electricity generation, which is roughly 50% of our electricity, but that provides like 85% of the carbon emissions from the power sector. So, especially given that those are large point sources, surely there will be a large focus on addressing carbon emissions there. The second big number is the one of petroleum and transportation. That's the 526 megatons. So obviously, if you take the Willie Sutton philosophy, which you all remember why he robbed banks, that's where the money was. If you want to control carbon, those are the two big places you're going to look. And both, obviously, are quite relevant to how one addresses energy efficiency in the supply chain, and clearly need to be addressed here. One might note that although in the industrial column there is much more, if you like, diversity of fuel source. I'm using here the word fuel loosely since electricity isn't the fuel, but that when you add them all up, when you look at the bottom line, the total line, of course, the numbers are not insignificant, somewhat smaller than the buildings and transportation, but still significant. However, there I would argue that the policy design will certainly matter. We don't know what that will be in detail, but if anything, since industry can move to China much more easily than your house or your car, that the political realities will no doubt focus, I think, on those other two columns, on the electricity and transportation sectors. So that's the 50-year perspective that I emphasized earlier. As we mentioned, that's the time it takes to turn over the infrastructure. We have the climate change clock that runs out. The budget runs out roughly by mid-century. This invokes a possibly apocryphal story about General Lyautey and his tree. Lyautey was a French general who is rumored, upon coming back from long campaign, asked his gardener to plant a particular tree at the corner of his chateau. The gardener apparently responded or protested that such a tree took 100 years to mature, and allegedly Lyautey's response was, well, then plant it this afternoon because we have no time to waste. And I think that's the kind of spirit that one is really talking about here in the climate change issue. This leads to other issues of needing a portfolio approach that I won't go into in detail, but let me just say that, you know, we often hear that the response to these challenges is going to have to be a significant portfolio of different technologies. You know, there's no silver bullet kind of answer. And one can legitimately wonder whether that is just kind of a statement of technology sandbox players like us who just want to do a lot of different things, or whether there is kind of a more rational underpinning for that statement. I would claim it's the latter. And the reason is scale. We've talked earlier about the scale of the energy business. In a similar way, the scale of any technology that's going to have a substantial displacement in that energy sector is going to be huge. And if we try to shoehorn that into, say, one silver bullet, we get into very, very serious problems. Let me give you one example from both the electricity and the transportation fuel sector. if, and you'll have to take my word for it at the moment, I have a model here I could show you, but I won't. If we, for example, say that coal with carbon dioxide capture and sequestration in geological formations is the silver bullet for carbon-free electricity, there's no law of physics that prevents that from happening. However, there is the little detail of about 150 million barrels per day of supercritical CO2 injection. I remind you today we have around 85 million barrels a day of oil. Again, there's no law of physics says you can't move around that much fluid. But, you know, when you think about it, the logical response is kind of oy vey. And, you know, I mean, there's going to be public acceptance issues, huge infrastructure issues, liability questions, et cetera, et cetera. And so, you know, it's much more likely we need some of that, some nuclear, some wind, some solar, more fuel shifting to gas, to natural gas, et cetera. Similarly, if you look at the popular solution du jour for transportation sector, a few years ago, it was the famous hydrogen and freedom car, about which one hears identically zero anymore. The du jour solution today is biofuels. Switchgrass is the new word in the president's vocabulary. Biofuels is wonderful. If we want to displace a substantial amount of fuel, petroleum-based fuel with biofuels, and we realize that our ability to convert sunlight into fuel energy today is about half a watt per square meter. And you just calculate. You pick your number of barrels of oil per day, 10 million, and translate it into watts, energy per day. It's power, it's watts. You start to realize that, you know, it's the same problem. We are in a terawatt business. That's the scale of the energy business. Remember, 14 terawatts. So you want to make a big difference, you know, terawatt is kind of the currency. Well, there are roughly 25 terameters squared of arable land in the world. At a half a watt per square meter and terawatts, you're using terameters squared of the world's arable land. So there are going to be land use issues, water use issues, fertilizer issues, all kinds of system constraints that are not really being considered very much. Or, of course, we get, you know, modern biotechnology produces the monster plants that goes from a half watt to 5 watts per square meter, and we solve the problem. But anyway, there are huge system challenges, and once again, my message is that's why the statement is really true, that we're going to need contributions from multiple technologies in both the power and the transportation value chains. This is what was going to provide all the backup for that, but I am going to go finish that. That's the silver bullet, many pathways, and as I say, efficiency. In fact, so here's a bunch of pathways: efficiency, alternative fuels, carbon-free electricity, et cetera. I just want to make one point on the first one, the efficiency, which is, and of course today you're discussing energy efficiency and supply chains. One point to make in that scenario I skipped over would have been a vehicle to make it, but I'll just state the conclusion, that if you look at any rational economic response, let's say to a carbon policy with BITE, no doubt about it, we cannot solve the problems that we put up to frame this issue about demand, security, environment without efficiency being a big, long pole in the tent. If we do not reduce the projected primary energy use, let's say for mid-century, by at least a third with efficiency beyond business as usual, there ain't no way we got any chance of meeting those goals. And it's still going to be hard. But efficiency is essential. Number two, efficiency is where you get the quick response. So if a carbon policy, you know, if President Bush next year signs a carbon policy that immediately imposes a $100 a ton carbon emissions tax, which has about a 10 to the minus 9 probability, I mean, virtually all the gains you would see in the next decade would come from efficiency. Because any technology introduction in this highly inertial system basically takes 20 years to get real traction, which again is why we have to start today. And the only thing you'll see quickly coming in, relatively quickly, is efficiency. And that's again why the kind of discussion I think you're having is very important as one part of that puzzle. Now I'll change the industry structure. So I'll just finish by saying that going back to what at MIT we hope to do, clearly there's a lot of research going on now. There will be ongoing research in what I would call the traditional mode of, you know, faculty members, students, et cetera, that will go on. But what we want to do is add on top of that what we believe will have great value added and impact, and is really to integrate our consideration of key energy problems across disciplines, bringing scientists and engineers together with planners and management people, and economists and political scientists, because in the energy business, deployment at any scale depends upon your ability to have a good impedance match with social requirements and real-life constraints. And to do so, we believe there are many attributes that will have to be brought to this. We, of course, feel that we happen to have a lot of those, as do other institutions. But things like really understanding and being a leader in technology innovation, we think is very important. Certainly, the ability to work across departmental and you know, traditional lines. You know, at most universities, for most of their history, it was assumed that God created the world according to physics, chemistry, mechanical engineering. We've, I think, realized recently that doesn't seem to be the world works, and bringing together disciplines is essential for addressing complex problems. This is a complex problem that you're dealing with. We very much hope that this is going to be one of the focal points of our energy work, that is really addressing the complex, down and dirty problem of how does one get much more efficient supply chains, how does one really look at the global freight systems, how is it going to evolve in a world of gigacities, et cetera. New kinds of constraints, new technologies will come in, and I think it's a very important and exciting area. I hope today's meeting goes well and provides us with some good ideas for us and others to work in research to try and clarify these important problems. Thank you.
President Moniz, can I ask a quick question? You talked about the carbon trading system and
Yeah.
how transportation could be pulled into that. Can you say a bit more about that, about the mechanism itself, and also how maybe transportation could relate to that as such?
Well, it remains, first of all, quite unclear as to what policy will actually look like. I would argue that the ideal approach, from my point of view, is not a cap-and-trade system, but a tax, a carbon tax. This obviously has political challenges, although most people seem to recognize it as a much more efficient approach. It is nominally not the ideal approach in the sense that, let's say, if your goal is to cap carbon, then cap and trade seems to be the obvious approach, because you are capping the thing that you want to control. And the trading that implies that hopefully you will do it in the most economically efficient way by having the private sector then, you know, find the cheapest ways to do it. One of my favorite allegedly Yogi Berra statements, although I really doubt it, is that in theory and practice are the same. in practice, they're not. And I'm afraid that will be the case of a carbon cap and trade system. When you begin to think through what it would mean to actually do the kinds of monitoring and verification, avoid gaming of the system, move down to small players in the system, because you'll end up, how are you going to do it for, let's say, tomorrow's 1 kilowatt combined heat and power system in a house? It just, and then when you think about extending that to a global regime, and ultimately, if it's not a global regime, we also can't succeed. China may not come in at the same time, but maybe they come in 10 years later, if we're on a success path. Well, how are we going to do a cap and trade system with verification in China? Or, other countries, but in China, where despite some lingering misconceptions, Beijing has virtually nothing to do with what actually happens on the ground in most of China. So all I'm saying is I think at a practical level, cap and trade gives me a huge problem. I'm not claiming tax solves everything. There will clearly be political challenges there, but it's a lot easier to put a price on a carbon atom. You can do it much more upstream on the fuel itself, and then it propagates down through the system. And there's a different kind of economic and consumer readjustment. Consumer, I'm including here commercial enterprises, consumer readjustment to those energy costs. To make it, to increase the probability of going that way from 10 to the minus 6, 10 to the minus 5, I would say that it's very important that it be a revenue neutral tax. In fact, I should say in a public attitude survey that we did last year for a study on coal that we published about a month ago, it was interesting, I think, that the sample of Americans, it was over 1,000 Americans in the sample, only U.S., that the resistance to the idea of a fuel tax was dramatically changed when the question was phrased as, would you support a fuel tax if it were accompanied by an equivalent reduction of income taxes? And the answer, and then almost half of the people said that would be a good trade-off. Now, the trouble is, again, it's the same in theory and practice business because it sounds good, but immediately when you think about it at the next level, there are what will be euphemistically called distributional effects to be addressed. That's where all the friction comes in the economic efficiency of the implementation. But nevertheless, that's what I would argue would be a good way to go. Now, having said that, I just said, but it's not going to go that way. I think what's actually going to happen, and this is where transportation will certainly come into it, is that we will have the public face of a carbon policy will be a cap and trade system. How transportation comes in is not entirely clear, but I'll say why I'm going to downgrade the importance of it. It'll be a cap and trade system, however, with a low safety valve. So the cap will not really be on carbon, it will really be on price. And that price will be low enough to be politically palatable. Look, it's only $10 a ton of CO2, which is 10 cents a gallon of gasoline, okay? However it's implemented. But of course, that price will not support a major carbon reduction, which might be noticed. And so what we'll have is we'll have an entirely additional shadow carbon policy that will continue with every semi-wacko policy instrument you can think of. You'll have continued renewable portfolio standards, some version of CAFE standards, tax credits, production tax credits, loan guarantees, all servicing various kind of little points, little targets in the economy. You know, it can work, But it's clearly then a very confusing, economically inefficient approach, but it'll be politically palatable because it'll be a hidden way of keeping the carbon price low while doing something if you're serious, and translating that into the international context will be quite a challenge. Because again, then you'll see there will be no harmony between what people are doing in different industrialized countries. It'll all look very different, and I think it'll complicate the spread to a global regime. Otherwise, I'm completely optimistic. All right. Any other questions or comments? Good, thank you.